So we are looking at lesson 6 now. We're going to be talking about quadratics, otherwise parabolas. We're going to be talking about radicals, and then we're going to be talking about polynomials, where you have these full-on equations with more than one term. Alright, so here we go. First of all, we are going to review solving quadratic equations with no calculator. So in the last lesson, we looked at different ways, different forms of quadratic equations. It was like vertex, standard, and then the factored form, otherwise x-intercept form, and what they show us. Now we are going to discuss the different ways to solve quadratic equations. So there will be an equal sign somewhere. Alright, method 1. There are 4 methods. This is the first one. Solve by taking the square root, and don't forget that the answers of these problems can be what? What goes in these blanks? Positive or negative. This is huge because a lot of people forget this. Very few remember it. So we have to include what? The plus or the minus. Okay? So, what I want you to do is I want you to be concentrating on your fundamental standard quadratic equation, that standard form. And from this, I'm going to tell you what method you should use and why. Okay? So, method 1, what would we do to both sides? Square root. And when we do that, we're going to have a plus or minus square root of 36, which is a plus or minus 6. And yes, if you feel comfortable to write it out like this, I'm okay with either one. Okay, you don't have to separate them. Now, let's look at our next example. What do I do to solve for r? Square root. So I'll have what? R minus 3 equals plus or minus 5. Because you did take the square root of 25 and you remember the plus or minus. So again, what I really have here are 2 answers. Some people feel comfortable by putting this 3, by adding it to the right side, and that you would have r is equal to 8 and r is equal to negative 2. But some people don't feel comfortable doing that. If you're one of them, please go ahead and just break this up into 2 equations. One is a positive 5, and the other one's a negative 5. So that when you add this 3, you will get 8, and when you add this 3 here, you'll still get this negative 2. Whatever you feel comfortable, just please make sure you get both answers. Okay? The last one, what do I do? Square root. So it'll be k plus 1 is equal to what?
Positive root negative square root of 17.
There you go. So this square root of 17 is not a pretty integer like these other ones were, where 5 came from 25 and where 6 came from 36. This one you're going to leave as a root. And whenever you subtract the negative, or subtract the 1 over, you would get a negative 1, then plus or minus. Okay? This is typically the form that you will write with square roots being added and subtracted. Is this equivalent? It is. But is it what normally is written? No. And the reason of that being is they just don't want you to confuse that this goes underneath 17. Cool. Alright, so please stick to this form in that regard. Alright, so next method. Solve by factoring. Remember, you can only solve by factoring if the equation is set equal to what? 0. Okay? So not 1, not 20, you have to set it equal to 0. Now, this one is set equal to 0, this one is set equal to 0. But this one we can set equal to 0 by subtracting the 48. Now, of these 3 that are up here, one of them I don't have to set equal to 0. Can someone tell me which one of these I don't have to set equal to 0? Not the first one. The second one. This one I don't have to set equal to 0. I could go straight to this, and can you tell me what the answer would be? Plus or minus 8, because you took the square root and you have a plus or minus. You with me? Now, if I go back over here, look at this. I did not set it equal to 0. I did not set this equal to 0, and I did not set this equal to 0. Just like I didn't set that one equal to 0. Please tell me, conceptually, with understanding in mind, why do I have to set those equal to 0?
Because those ones have variables with different exponents, like 2, 1, and then a constant, whereas the b squared minus 64 just has b squared but not a b.
Perfect. So, ax squared, bx, and constant. You with me? So just like Shane said, this one, right here in the middle, did it have A, B, or C, or all of them? What did it have? It just had A and C. What do these have? A, B, and C. So what do you think the rule is that if it has these, then I have to set it equal to 0? Just A and B. Nicely done. Only A and B are required for it to be set equal to 0. For instance, if I had 2x squared minus 4x, and I had that set equal to 0, the reason why I would have to is because I have an A term of 2 and a B term of negative 4. Guys, can you tell me what the second step would be here to solve this? Pull out 2x. GCF. Now, I have one answer right here, which is 2x. What would that be? 0. Nicely done. What would this be? 2. Guys, this is why you have to set quadratics that have the A and B term set equal to 0. Otherwise, if they don't have the A and B term, you can just solve it. You don't have to set it equal to 0. Now look, people who don't know this, this is an example that I just made up just now. If they don't set it equal to 0, this is what they'll probably do. And guess what next step that they're going to try to do right here? They would divide by 2x. So that this would end up becoming x, and this would become what? 2. Get this. They got half of their answers. They didn't get both of them. Just like over here on this slide, if you don't remember the plus or minus, you're only going to get half of your answers. Okay? So please be aware of that. Make sure that you know that the A and B are the only ones required for you to set equal to 0. Alright, so let's go ahead and factor this one. Okay? So I have my own way of showing, and yes, it is similar to the full method, it is similar to the box method, and some of you already are good at this, but some people aren't, and I want to make sure that we get everyone up to speed. Okay? So the way that I would teach quadratic factoring would be this. These two will multiply to get x squared. X and x. The next step that I would concentrate on is are these two numbers would multiply to get a 2. Not a positive, not a negative, just a 2. Which is 1 and 2. Now from here, some people already know this, a lot of people don't. I would look at these numbers, and if I added them, they could produce a 3 for me. If I subtracted them, they could produce a 1 for me. This is the new stuff that I'm trying to expose to students because I need a 3. And that 3 is right here, which comes from these numbers. So because that 3 worked from these numbers, I'm going to put a 1 and a 2. Or I could have put a 2 and a 1. Why are the positions interchangeable? Well, it's multiplication for sure, but also the more important is that it's x and x. The location of 1 and 2 doesn't matter because the other ones are exactly the same. Okay? So let's go ahead and put 1 and 2 like this. The last step we have to ask ourselves is I have to worry about signs now. This is the first time that I have to worry about signs. Okay? Are they both positive? Are they both negative? Or is one positive or negative? They're both negative because they will multiply to get a positive 2. And then they're also both negative because negative 1 and negative 2 will add to get that 3 that I need. Okay? Now it does seem like a lot, but I promise you, you get good at this method, even the more difficult factoring quadratics are going to be very easy. You no longer have to worry about factoring by grouping. which is a little bit too much. To me, factoring by grouping is like the quadratic formula. It's just so many steps, okay? All right, so what's my answer for this one? And x equals 2. Nice. And yes, you could just write it like this if you wanted to as well. Let's go to the third problem over here. What would be step 1? Divide by 2. GCF. Yeah, we already subtracted the 48. And the next step is to divide by 2. Whoops, not 10. Whoops, not 12. 24. So now, if I'm a person that struggles with quadratics, this 2 is still a nuisance to look at. I would probably divide by 2. And I know that 0 divided by 2 is still what? 0. So now this one's easier for me to look at. Look at the steps. And again, learn the new steps because they will help with harder problems. Not this one, but they will help with harder problems. Here we go. The first 2 terms will multiply to get m squared. What are they? M and m. I'm hungry for candy. Alright, the next 2 will multiply to get 24. Here we go. Now it's different. Okay? And a lot of you can jump immediately to the answer because you have good number sense practice that you learned way back when in elementary. Okay? A lot of people don't have that, so I want to give them a systematic way to approach this. I would look at 24 and find factors. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, if I pass 4, I'm just going to say 6, 4, 8, 3, 2, you know what I'm saying? I'm just overlapping. So this is how I know I've accounted for all of them. Okay? So if I have 1 and 24, look at this. If I have 1 and 24, what 2 numbers, this new way that I'm showing you how to factor, would those produce? 25 and 23. But we need a 5. So we chose poorly with that. Say we chose 2 and 12. What numbers would that produce? 14 and 10. We need a 5. So my suggestion to you is don't pick the extremes. Pick close to the center as most as you can, and then trial and error out from there. Okay? So if I picked 4 and 6, okay, what would 4 and 6 produce? 10 and 2. But I need a 5. So let me do the 3 and 8. And yes, sure enough, there it is. We have 11 or 5. So this will work. We just have to look at the signs at the very end. So we have 3, we have 8. And they will multiply to get a negative. So I know that they're opposite signs. And who wins? The 8. Because how else are you going to get a negative 5 when you add 3 and negative 8 together? So that you get m is negative 3 and m is equal to 8. Okay? They will help with the more difficult ones. Alright, method 3. Solve using the quadratic formula. We have to memorize this, okay? If I looked at this, is there a way that I can see that it would be the quadratic formula immediately? I mean, there's really not a trick that'll show you, hey, this is quadratic formula. You would have to try the factoring method first, and then if it didn't work out, then you would know to use the quadratic formula. Okay? So let's try that. X and x will produce x squared. What numbers produce 2? 2 and 1. Now, I know that 2 and 1 will multiply to get a positive, so they're either both positive or they're both negative. Because of this, what will they both be? Positive. So here we go. This is going to be x squared. 1 and 2 give you 3, and this did work out. So the answers are x is equal to negative 2 and negative 1. Now I know it told us to do the quadratic formula, but it's only for practice. But would you actually do the quadratic formula on this one? No. No, you would do it exactly the way we just did. Okay? But if they didn't work out this way, and you didn't get numbers here that satisfy this polynomial, then you would have to use a quadratic formula. Okay? Here we go, real quick. X equals negative b, and b is 3. Okay? Plus or minus b squared minus 4ac. Again, you can only do this when it's set equal to 0. C is 2. And then so on and so forth. The coefficient of your a squared term, or your a, was 1. And then you have b. So b is this positive 3. And if it was a negative, you put a negative inside of these parentheses. All over 2a. Questions? Next step that you would do is you would solve this. So you get 9. Then a negative 4, positive 1, positive 2 becomes a negative what? 8. So you have 9 minus 8. You have this negative 3 all over 2. 9 minus 8 is 1. So it's negative 3 plus or minus 1 all over 2. That's saying negative 3 plus 1 over 2 and negative 3 minus 1 over 2. What's negative 3 plus 1 over 2 equal? Negative 1. And then negative 3 minus 1 is negative 4 divided by the positive 2, which give you the negative 2. Okay? Alright. This next one, do I need to set it equal to 0? Yes, I do. I have to, because what's the a term that you see? 1. What's the b term? Negative 4. And remember the rule, if you have a and b, you have to set it equal to 0. Okay? So you have j squared minus 4j minus 9 is equal to 0. Okay? Now, again, we're not going to factor it by hand. We're going to go ahead and do the quadratic formula, just the setup first, and then we'll factor it by hand. Here we go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Guys, what's b? Negative 4. What's a? 1. And what's c? Negative 9. There's your setup. Okay? And if you worked it out, let's do it the new way that I showed you as far as by hand. These two terms will multiply to give me this. What are they? J. Now these two terms will multiply to give me a 9. Give me different factors that give me 9. 1 and 9? 3 and 3. Which ones, what we've talked about, would be the ones that I want you to try first? 3 and 3. Those would be the ones that I want you to try first, right? So if you put 3 here and 3 here, before we do that, what do 3 and 3 produce? 0 or 6. 0, 6. What do we need? We need a 4. So those don't work. What do 1 and 9 produce? 10 and 8. What do we need? A 4. Here's where we know we have to do quadratic formula. Do you understand? Okay, so let's go ahead and do that real quick, quadratic formula. Now that we've verified real quick why we have to do it. So we have a positive 4 here, plus or minus. And let's take care of negative 4 times 1 times a negative is a positive 36. And this is 16. So it's like 16 plus 36 all over 2. So you get 52. Do you agree? You get 4 plus or minus, and you get 2. Can someone tell me what I do next?
Try to find the square root of 52.
Yeah, square root of 52. Let's simplify this radical. Okay, so we're going to simplify root 52. What did I tell you this week that the understood number goes there? 2, right? So because it was a 2, which are the squares, what are the numbers that I told you this week that we should go through? 4, 9, 16, 25, and so forth, right? What if they were cubed?
Wait,
8, 27, which is 3 cubed, 64, 125, okay? But because this is an understood 2, we're going to do this list right here. What's the biggest number that you can see that we can take out with 52? A 4, right? So let's do this 4, and we get 13. Nicely done. So that when we pull out the 4, we get what? 2 root 13. So 4 plus or minus all over 2. What's the last step?
you can divide each term by 2.
It can divide each term by 2. Does that mean this term as well? No. Just the 2 and the 4. Okay? And if you don't see that, please, common denominator understanding shows that we could have written it like this as well. Okay? So then it would become 2 plus or minus root 13. And yes, some people feel comfortable or more comfortable writing it like this by showing both of them out.
J equals 2.
Oh, J, thank you. J equals. So J is equal to all that. We would say that you misspelled J. All right. Let's go to now method 4. The last one is solve by graphing using your calculator, round to the nearest 100. So 2 decimal places. Please grab a calculator if you don't have one yet. Now here's the thing. With what we've learned this week, if we use in our calculator, are we going to be graphing this? No. There's a solve feature that if we do exactly like our paper says, it will solve for all of them. Real quick. The CAS, which is what you have and which is allowable on the test, will have the solve and the end-solve feature. Not slove. The end-solve feature. The CX, which is not allowed, this is allowed only on the PSAT and the SAT, not the ACT. And the CX, that's allowed on all of them. Okay? The CX only has the end-solve feature. You with me? So let me just educate you with this calculator. This will not give you all answers. This will not give you all answers. This will give you all possible solutions. Do you understand? So if it was x squared, it will give you the plus and minus forms. But if you were trying to do something with x squared on these, it would only spit out one of them. One at a time. Okay? So which one do we obviously want to use? The solve feature. Okay? So let's go to the calculator. Alright, so to continue, we're going to go ahead and erase this. We've pulled up our calculator. And to get solve, it's going to be menu 3, 1. Or you can actually type it out. Okay, so let's go to that real quick, and I'll show you both. Oops. So one for a new document, one for a calculator page. You can do menu 3, 1, and it'll go straight to solve. Okay, let's say you forget where it was. You could just type it out, and it's italicized until the last letter, then it pops straight up because it recognizes it as a program function that it has already. 3x squared minus 2x, so 3x squared minus 2x, and then it's minus 4. So minus 4 is equal to 0, comma x, and those are both your answers. If you wanted the answers to be in decimal form, you would just from here put a control enter, and it gives it to you in decimal form. Any questions, guys? Now let me show you something else. I want you to be well versed with this calculator, because when you take the ACT, you won't be able to use this, but you can find both answers. Okay, you ready? I'll show you how. So on the CX calculator, when you press menu 3.1, it will actually display what this one does as menu 3.6, which is numeric solve. Now watch, if I come up here, whoops, I'll put in, there's my in solve, okay? If I do this, it only gives one answer. It gave the first one. You with me? How could I get the next one? Well, there's two ways that I could do this. I could assume that it's to the left of that number or to the right of that number. Okay, so here we go. I could say, is there another answer, comma, after this one? You with me? So I could say like negative 0.9, you with me? All the way to, let's say, infinity. What is it that I did wrong? What would I have to do instead of negative 0.9? Negative 0.7. So think of it as a number line, okay? So if this is a number line, and my answer that we just found was negative 0.868, we want something over here. What I just did was something here. So that's why it gave me, if I restricted it between negative 0.9 and infinity, it's still going to give me that same answer. But if I do it like negative 0.7, it gives me the other one. You see what I'm saying? And I want to do it as close to that answer so that I don't miss something that could possibly exist so close to that other one. Okay? So just a little bit of extra knowledge with the calculator so that it not only helps you with PSAT and SAT, but it actually helps you all the way through ACT. Because again, remember, you're not going to use the CIS with the SAT. Alright, so our instruction said to the nearest hundredth. So we would say negative 0.87 and 1.54. Questions?
Can we answer in roots?
Well, you could answer in roots, but specifically it told you to do the nearest hundredth. Okay? Alright. So let's do the next one. So it's going to be negative 2x squared. Menu 3.1, negative 2x squared. I might be going a little bit too fast. Menu 3.1, negative 2x squared. Minus 4x plus 5. Minus. Not the negative button. Look at, there's the minus, there's the negative. Make sure that you understand that you're doing the minus. Okay? Minus 4x plus 5. Is that correct? Okay. Comma x. Whoops. I gotta set it equal to what? 0. And that's the other thing. If you don't have an equation and you just have an expression, it's not gonna solve for x because it's not saying, it's saying you don't have an equation there. So you have to have it like an equation by setting it equal to something, whether it's 0 or another number. Okay. Let's control enter. And then we get negative 2.87 and 0.87 because we're rounding to 2 decimal places. Questions? Just calculator knowledge and practice. Okay? So that was the fourth method. Now what we're going to do is we're going to add, subtract, and multiply polynomials and then just like simplify the expressions and whatnot. Okay? So the first one, because this is addition, all it's really doing is just distributing on this term and just distributing on this term a positive. So you get, without parentheses, negative 5x squared plus 16. Can someone tell me what number is there? A 1. An understood positive or negative? Positive. So all this is going to do is just remain the same. So you get a positive, stays negative. So now, I know all of y'all would have it just on pencil or pen, so just one color. That's a good way to organize all your square pieces. So you get negative 2x squared. Then you have your x terms as just plus 7x. And then your constant terms, what would that combine to? Plus 5. And there's the simplest form. Any questions? Okay, So this negative distributes to get a negative m and a negative 4. The positive distributes to keep the positive, to keep the negative. And then there's an understood positive 1. 2m minus 1. So if I look at all of my constants, what would that give me? Negative 11. And now if I look at all of my linear terms of m, these go to what? 2m, because these cancel to 0, right? So 2m minus 11 would be your final answer. Easy, just practice, guys, okay? Now, equations containing radicals or variables in the denominator. We have to remember we're going to rationalize all that good stuff. But remember, when solving equations containing radicals, that you need to check for and eliminate solutions that do not work. There's a fancy word of that. What was that word that we were taught? Extraneous. Extraneous solutions. These are the ones that you could get mathematically, but you gotta check your answers. Okay? It's even possible that even though you get answers when you solve, none of the solutions could work. So you gotta check them. Alright, here we go. Let's do the math. Let's get x alone. What do I do to both sides? Square. So I get 16 is x minus 1. So what's x? 17. Question you have to ask yourself is, does 17 work? So if I put this into my original problem where x is at, does it work, guys?
Yes.
Yeah. So this is not extraneous. This is a legit solution. So this works. Let's go to our next one. What do I do? Square both sides. Now what? Add like terms. Let me move this 1 over here. Let me move this 2 over here so that I get z is equal to 3. We have to ask ourselves, does this work? So if I put 3 here, I get square root of what? 8. If I put 3 here, what do I get? Square root of 8. Does this work? Yes, it does.
When there's only like one solution, isn't it always right?
No. Well, it depends on more of the problem. I don't want you to build that understanding. I want you to build the more understanding of, I have to check it. And I have a shortcut for you on that. I have something that I want you to think about that will then tell you I don't have to check for extraneous solutions. Do you understand?
Yes.
Okay. So, last problem. What do I do to both sides? Square it. Can someone tell me, if I square the left side, what do I get?
You have to do w plus 1 squared in parentheses.
What was the M word that we used this week? Multiplicity. So this is actually a foiling or distribution of this. So I get w squared plus 2w plus 1. Is this quadratic now? Yeah. Do I have to set it equal to 0?
Yes.
Yes. Why? Because there's an a and b term. So let's get all of our terms to the left. And we should have w squared, what? Minus 4w minus 21. You with me, guys? Alright, here we go. The first two terms will multiply to give me what? W squared. The last two terms will multiply to give me what? 21. What are numbers that can multiply to give me 21? And also? But I wanted you to do the ones that were closer together first, right? What two numbers will this produce? Are one of these what we need?
Yes.
Yep. So we need to write this. Where do the positives, where do the negatives go? Perfect. So my answers are what? W equals 7 and negative 3. So here's what Shane was trying to say earlier. If there's one answer, it must work. Here's what I'll say. If there's more than one answer, for sure, you should check for extraneous solutions. My opinion is you should check all the time. So if I put 7 here, I get what? Root.
Well, that's not the problem.
Oh, my bad, my bad. What am I doing? Thank you. If I put 7, what I meant to say is here and here, what do I get on the left side? 8. What do I get on the right side?
Yeah.
Well, the right side would be,
That's 60 square root of 64.
this would be 42, right? 42 plus 64, so it'd be 8. That was fast. Nice job. So 7 works. If I put -3 here, I get -2, right? -18 plus... It can work because I can't take the square root of a number and get negative, right? So -18 plus 22 is 4, which would give me a positive. Now here,
Wait, can't you actually?
well, this doesn't work, right? This doesn't work.
Well, a negative number squared can.
Become positive, but the backwards cannot happen unless they're imaginary numbers with I. Okay? So -3 does not work. -3 is extraneous. Now, this is huge what I'm about to tell you, okay? As far as understanding goes, this is how you'll know I need to check for extraneous solutions. Check this out. Did we check on this slide? No. What's the parent function? Y equals x squared. Which is a graph that looks like this. What's the domain of this graph? All real numbers. Because the domain is all real numbers on the parent function, we don't have to check for extraneous solutions. Or the parent functions here. They're all quadratic, right? So if they're all quadratic, what's the domain of that function? All real numbers. We don't have to check for extraneous solutions. All quadratic, right? We don't have to check for extraneous solutions. All quadratic, we don't have to check for extraneous solutions. Well, these are just simplifying. And I just noticed we didn't do this one down here. We'll do that in just a bit. But why do we have to check for extraneous here? They're not quadratic. What's the parent function?
Y equals the square root of x.
Square root of x. And this graph, what's the domain? 0 to infinity. It's not all real numbers. So let's think about this. Parent function wise, the ones that will not have extraneous, that we don't have to check, so no check answers required, would be for like what? X squared, x, right? X cubed, and all of those, right? What other ones do we not have to check? And in your mind, you're remembering that the domain has to be what? All real numbers. So think of all the parent functions that you know that the domain is all real numbers.
Y equals anything.
Y equals what?
Anything, like any constant.
Well, yeah, but I mean, so do you remember this one? Absolute value. Do we have to check for that? We actually do. Because this one has a little bit. This is very similar to this, in that you have to check for plus and minus answers. You with me? It depends on plus or minus answers. What's another one that has all real numbers? Does this one have all real numbers? For the domain? No. So this you would have to check. You would have to check for extraneous solutions. How about this one? You have to check? Yes, because what's the domain here? If you don't remember, you have to refamiliarize yourself with parent functions. The domain is everything bigger than 0. You with me? Do you all understand my point? Okay, so if the parent function is not all real numbers, you're going to have to check for extraneous solutions. Okay? And the reason why I say that for the other one, what could x be? Well, how would you solve this? Wouldn't this be the same as that? Right? Which is negative 4 is the answer here, and 6 here. Now I know this one will give the answer. It will give the answer. But when there's squared pieces over here, whenever it's compared to square roots, you see what I'm saying? You do have to check for extraneous solutions. So let's put it this way. Let's refine this. If it's just the absolute value and a bunch of constants, yes, you don't have to check. But most likely you'll see this absolute value with like square roots and stuff, where you do have to check. Last thing that I'll show you, and then we'll go back to the one that we skipped. We got negative 4 and 6, did we not? I want you to solve this fast. The parent function is this. That means the center lies at 0. Where does this center lie? At 1. This is the center, and this is the jump. 6, negative 4. If you did not know that already, you can do it like that. Okay? Last but not least, with this example, what would the answer be there?
4 negative 6.
It's not possible.
Oh.
This is not possible because when can you take the absolute value and get something negative? It has similar properties to when can you take the square root of a negative? You can't. Do you understand? So even though the domain is all real numbers, it's still not possible because other conceptual understanding. Okay? Good stuff, guys. Good stuff. Let's go back to that one that we skipped. Oh, it's because I was on the blank sheet. This one right here at the very bottom. So distributing this 2 gives us 6t cubed minus 4t squared plus 2t. Distributing this negative 7 gives us negative 21t squared, positive 14t, and a negative 7. Now, combine like terms and tell me what should I write as my final answer.
16t minus 25 squared t squared plus 16t minus 7.
Perfect. Easy enough. Okay? Alright, let's go to a couple more slides. Oh, one more slide. One more slide and then we will take our quiz. When solving equations with variables in the denominator, remember to eliminate any solution that would make the denominator equal 0. Eliminate any solution that makes the denominator equal 0. We kind of were just talking about that, weren't we not? This is saying that there will be answers that will work, but if it makes the denominator equal 0, guess what? They're extraneous. Do you understand? Why? Because you can't divide by 0. Guys, what's this equal?
That's not.
It's undefined. What is this equal? What is this? That's multiplication. What does that equal? 0, right? What does that equal? 0. So please make sure that you've made note that you can't divide by 0. All right. What would y'all do to solve the first one?
Move the left term over to the right because they have a common denominator.
Okay. So he's saying move this thing over there.
That would be 3x minus 1 over x.
And I'm just showing intermittent work for other people. Shane went immediately to that. Then what?
Multiply the x plus 2 over.
Then multiply both sides by the denominator to get rid of it, because this cancels to 1. But what you do to one side, you must do to the other, so you get 2x plus 4 equals the leftover numerator over here. And then I see 3, I'm just going to move it over here by subtracting 2x, and then I'm going to move this 1 by adding it. X is equal to 5. Do I have to check my answer, yes or no? I do.
So it's 1 over x.
Because my parent function is this. And the domain is not what? All real numbers. So I have to check my answer. If I put my answer, x is equal to 5, in all places that could make the denominator equal 0, if it doesn't make it 0, I'm good to go. Y'all with me, guys? Do y'all understand how that works? Because I can't divide by 0. What if I got x is equal to 5 and 2? Would that work? Yeah. How about 5 and negative 2? No, negative 2 would be extraneous. Only 5 would be the other one, or would be the one that works. Now, we got to the answer of x is equal to 5. But I want to make you faster and I want to make you better. What could we have multiplied my original problem by on both sides? Basically, everything could have been multiplied by something to make this problem a lot easier immediately. X plus 2. It's called the least common denominator. We talked about this, I think, yesterday. So distribute on all 3, what would I get?
X or
1
plus 2x plus 4.
plus 2x plus 4, because you're distributing this across the second term. So it's like 2x plus 4. And what would the last one be?
Equals 3x squared.
Equals
Or 3x squared plus.
just 3x. Because when you distribute, you're canceling the denominators, right, to forms of 1. Okay? So now, notice how I kept this parentheses. Why would I write those parentheses? You're starting to think more and more progressively through problems the way I kind of wanting to show you. Why do you think I want those parentheses? Especially this one.
Because it keeps the x isolated.
It keeps the x isolated, but because there could exist sometimes where this would be what? Net minus. And if it's minus and I don't have these parentheses, I'm going to miss that distribution. Do you understand what I'm saying, guys? So, adding all this up, we get 2x plus 5. And if we just subtract that over, we get x is equal to 5. A lot less work, more efficient to get to the same answer. Okay? So let's do that trick that we just did, the LCD, right here. Before we do the trick, we have to know, what are we multiplying? What is the least common denominator? X squared minus 3x. Now look, if you don't see that, this bottom piece, do you agree with me that it factors to that? So, look, this and this are over here, but these don't have both. Do you with me? So I'm going to multiply by a form of 1 right here, x over x. And I'm going to multiply this one by x minus 3 over x minus 3. You all see what I'm doing? But I'm going to do it in a way with an LCD that looks like this. Let me do it in red. I'm multiplying everything by this. Let's do it one at a time. If I distribute this across this first term, does the denominator cancel? Yes. What am I left with? 18. Let's do this again. I'm going to distribute this across this next term. Does the entire denominator cancel?
Or, yeah.
I mean, it does, but it has left over what? This x. Do you see what I'm doing? Which would end up becoming what? Negative 6x, because you got to multiply it with that numerator. And last but not least, if I distribute it here, the x's cancel, but what will be multiplied with the numerator? X minus 3 to get 5x minus 15. Let's move this over here to get a positive number. Let's add this over here to get 33. So x is 3. Now, looking at my original, and this is what Shane said before. If you get one answer, does it always work? No. And here's a perfect example of that why. Okay? So this would be what? No solutions. This is extraneous, which it doesn't work. So this would be no solutions. I wanted you to conceptually understand that it revolves around parent functions. Okay?